Hello everyone. Today we will be talking about the concept of functions. We will be doing a brief introduction to what functions are all about, what's the main idea behind functions. We will be looking at terms such as domain of a function, range of a function, and a few other terms. We will mostly be focusing on what are called real valued functions. However, I will also give you a flavor of what does it mean to talk about more generic functions. We will be looking at some examples of functions, and this should be the most fun part. We will be looking at how to graph or visualize functions, and we will be doing it in two ways. The smart way to do it, to be very honest, well, not smart, but possibly the lazy way to do it, is to go to Wolfram Alpha or Mathematica or some other software and let it do the job, which is totally fine. And we will not shun that policy. We will do it that way, but we will also learn how to plot functions by hand. And this is not just some old school way of doing things. As you will find, this is actually very, very useful. So let's start then. So what are functions? Functions are the basic building blocks of calculus and the major tool for describing world. So let me write it down. So functions are basic block for a part of math called calculus, which is something you will be using a lot, irrespective of whether you're doing physical chemistry or machine learning or quantum mechanics or thermodynamics. Calculus is something that does not escape sciences, and especially more so engineering. And what that really means, it's not just a building block for calculus, it is a building block or a basic block for describing. I will try to get better with my handwriting. This is one of the first videos this is the first video I'm recording for this series. So please pardon my handwriting. I will try to get better. So they are the basic building block for describing calculus, but also in general, describing physical phenomena. We cannot do any of this without the use of functions. So we will get into a bit of a mathematical definition of function in a little bit. But first, I just want to give you a flavor for what functions are. So when I first studied functions, I found them really confusing for a long time. And I hope I can help you avoid that confusion. Maybe some of you have already taken enough calculus that you're very comfortable with the notion of a function. But if in that case, this should be an easy refresher for you. If not, hopefully this will help remove some of the ambiguity that you might have regarding functions. So functions, to be very honest, are nothing but maps. They are a map for taking you from, let's say, United States of America. That's Alaska over there. That's Hawaii. That's very nice and full of beaches. I would like to be there. Please pardon my very incorrect map. So let's say this is USA. And you could imagine a map that takes you from USA. So normally when you have a map, what do you think when you have a map? You would say, well, this itself is a map, but here we are thinking of a map in a more abstract property. This is a map that gives you certain properties of USA. For example, it could tell you that in this map, let's draw copies of it. So in the first copy, we could draw a map where we say, and I'm gonna ignore Hawaii and Alaska for a little bit, just for the sake of moving these things a bit faster, and I'm going to approximate United States as sort of a rectangle. So let's say map 1 tells me which part of United States are full of mountains and which part of United States are flat and away from mountains. So, and I'm going to use a color red for the part that are full of mountains. So that would be approximately Washington State, Colorado, California. If you're from the Northeast, they also have White Mountains and things like that. And which parts are flat? Well, Florida is really flat, and you can say most of it is really flat, something like this, right? And maybe there are some mountains in the middle here and there. So this is your first function that takes you from the map of United States and tells you which part of United States has mountains and which part of United States are flat. And you could make it even more mathematical. You could say that if it's a mountain, I'm going to call it a 1, and if it's flat, I'm going to call it 0. You could have a similar map where instead of calling mountains versus flat, you talk about the temperature across United States. So you could say here, the red would be very cold, the Northeast is very cold, and California is nice and warm. So here you could say, and the other parts will also need to have some coloring. You might say, well, not everything is only mountain or only flat. So that's true. Here we have defined a function or a map which can take value only 1 or 0. But in general, you would like to have a function which takes all possible values between 0 and 1. Same thing over here. Here, your red could be cold and blue would be warm. So it's a map that takes you from, so now we are ready to get a bit abstract and put this concept in a formal way. You have a certain set of properties of numbers, and in this set you have different locations. Let's say you have 0.1, 0.2, 0.3, 0.4, 0.5. Maybe you have 100 of them, maybe you have just 5 of them, maybe you have just 1 of them, or maybe you have infinitely many of them, and we will discuss all this in detail. So this first map, this first set of numbers is called a domain, and a function is a map that takes you from this domain to another set of numbers called a range. And in this range, you will have another set of values. So if I had 1, 2, 3, 4, 5 values here, then I will need to have 5 values over here also. So it should be 6 on this side because I do 6 points on the right. So in this map, this point goes to this one, this point goes to this one, this point goes to this one, this goes over here, this one goes over here, and this one goes over here. This is an example of a map. So this domain could have very well been your United States. This little point on the left could have been California. This little point on the right could have been Boston. But now over here on the right in the range, you are not looking at the map of United States again, you're looking at a value of temperatures. And you're saying that Boston is hot or cold, and California is hot or warm. So more rigorously, now we are with this intuition, I hope it helped you. Maybe it made things even more confusing, but I think it conveys the basic picture. So with this map, we are now ready to describe what a function is rigorously, slightly more rigorously. In math, you can always get as rigorous as you wish. It's all relative. So let's try to do it a bit rigorously. So a function, and normally we use the label f, the letter f to describe a function, is any rule that assigns to each element in one set, which we called the domain, some other element in another set, which we call range. And the sets could be sets of numbers, it could be sets of points, it could be sets of places, as we saw in the map of the United States. And similarly, the range is also not just going to be 0 or 1 or a set of numbers. The range could also be anything. You could have a map where you take something in the United States and map it into one of its neighboring states. So California goes into Nevada, New Hampshire goes into Massachusetts, Maryland goes into Washington, DC, that's also a map. And this map would be from USA to USA because every point in the first set is going into some point in the same set. So the most common notation, or possibly the only notation to write what we wrote above in a formal way, is to say that you have X is some point which belongs to domain D, Y is some point which belongs to range R, and then Y is a function of X. This is a terminology you will be seeing in PChem, in physical chemistry, again and again and again. If you have ever seen an ideal gas equation, then you have seen something like this, where you say that the pressure is nRT by V. So here, for example, you could consider that your pressure corresponds to Y and your temperature corresponds to X. And let's say we are working at constant volume. So given a specific value of the temperature, this multiplication by nR divided by V is a map that gives you the corresponding value of the pressure. So that's an example in physical chemistry, but let's look at more basic examples as to what does it mean. So how am I doing on time? I don't want these lectures to be too long. I want to break them up into small parts so neither of us loses focus in what we're doing. And it would have been nice to be doing it in a classroom so I could have stopped and asked you questions, but hopefully whichever module this is being used in, the instructor, be it myself or be it someone else, would be able to get feedback from you on any of the topics. So let's look at examples of functions. The most simple example of a function is a straight line. A straight line going through the origin. So let's say we have an axis over here. This is my X and this is my Y. And we know that in order to describe a straight line going through an origin, it goes through here, we need only one parameter. Y is equal to mx, where m is called slope of the straight line. So it's inevitable that in any of these math modules, you will be using concepts from other math modules. We cannot really mention during the math module itself as to where do these other concepts show up, but in the associated material, we will try to refer to as to what are the other modules in which you can go and brush up your knowledge of, for example, what does the term slope mean? Or why is it that a straight line passing through the origin is called y is equal to mx? Why is this the equation for such a straight line? You will be seeing this later. So that's the simplest example of a straight line where x is the input. So here, y, it is the same as y is equal to f of x. So this notation, by the way, f brackets acting on x, normally you will see people mumbling f of x. Sometimes they will be mumbling it super fast, f of x, f of x. You know, this reminds me of when I came to the United States for the first time from India, and I would go to a restaurant and they would ask me soup or salad, but they would say it so fast and it would sound like super salad, super salad. I don't know if you know what I mean. So this is how it sometimes sounds like, f of x. You can try speaking it very, very fast. So here, f of x is simply, you take x and multiply it with some slope m, and that gives you the value of y. So that's the simplest example of a function. We can consider more examples of a function. What if the straight line does not go through the origin? In that case, so now we are talking about straight line which might or might not go through the origin. So we again have the slope, but now we have to also take into account as to how far from the origin it is, right? So y is equal to mx would mean that when you take x is equal to 0, the value of this function is always 0. But now we are saying that so by the way, anytime you plot something, it's a cardinal error to not label the axis. So I just did a bad mistake here by not labeling the axis before I started writing. A plot is useless if you're not labeling the axis. So this is x and this is y. And in order to describe a line that does not go through the origin, two parameters are needed. So just to make a point here that m and c are parameters needed to describe the function. So here's a little quiz for you that I would like you to self-administer, and then we are going to stop today's video. So I want you to think about number of parameters needed to describe a function. For different functions. I should have written function on the left, but that's okay. So number one, straight line through origin. Number two, generic straight line. Number three, a Gaussian. And you can look up on the internet to see what a Gaussian is. And we will be talking about Gaussian and all these other functions in detail next time. Number four, an exponential. Number five, a quadratic. Number six, a power series with n terms. So I would like you to go and think as to what are the number of parameters you need to describe any of these functions. I will give you a hint. For the generic straight line we just saw, m and c are two parameters needed to describe it. So here the answer is 2. But what about the other ones? I would like you to think about it. And in the next module, in the next sub-module, so to say, we will start from this point. With that, let me number the pages. This was page number 2, and this was page number 1. Thank you very much, and I will see you in the next module.